Bushfires have a devastating impact on the Australian community. This fire ground is just a few minutes from my house, and family and friends who live just down the road evacuated their homes on the day of the fire. That day there were hundreds of fires burning across southern Australia. The most intense had so much energy they actually generated their own thunderstorms. Pyrocumulonimbus clouds, or fire thunderstorm clouds, towered over the fires to a height of 10 to 15 kilometres. And this illustrates the problem that we're addressing in our research, which is how three-dimensional interactions between a fire and the atmosphere can influence fire behaviour. The research has been done in two phases. Firstly, looking at 3 events where extreme, unexpected fire behaviour occurred, and then simulating them using a coupled fire atmosphere model. 2 of the fires were on Kangaroo Island, the third was a fuel reduction burn near Margaret River in Western Australia. At each fire, unexpected fire behaviour occurred, but when we looked at what was happening in 3 dimensions, we found very good reasons why the fires behaved the way they did. One of the fires came up a gully like a freight train. The flames were 50 metres high. Fire managers who we've talked to have asked the question, can you tell us about this in advance? Which brings us to the second phase of the project, coupled fire atmosphere modelling. The model we're using couples a fire model with an atmosphere model, so we can see how the fire changes the atmosphere around it and how that subsequently impacts the fire behaviour on the ground, and we've made some very interesting findings. The first is in the simulations, a wind change actually accelerates into the fire ground. This has got significant implications for firefighter safety on wind change days. The second main finding is that we're actually seeing that the fire plume can mix air down or entrain air from higher levels of the atmosphere. And since the air coming down has more energy than near surface air, it really raises questions regarding our current approach of near surface values in fire weather forecasts. The third finding, and perhaps most exciting, is that the depth of the boundary layer has a massive impact on fire behaviour. The boundary layer is the layer that's influenced by daytime heating, and on a really hot day it can be 4 or 5 kilometres deep, and the fire plume grows to that depth of the boundary layer. So the deeper the boundary layer, the more intense the fire and the more energy at the surface. So where do these findings take us? Well, in the short term, we'll be including some of the findings from the research into real-time fire weather forecasts as early as next fire season. And in the longer term, we'll keep on working towards real-time coupled operational simulations. Ultimately, it's about providing the best information we can to mitigate against the impact of bushfires, to minimise risk during fuel reduction burns, and to ensure the safety of our firefighters and communities. And the research shows that in order to do this, we need to include the 3-dimensional interactions between a fire and the atmosphere when we're anticipating fire behaviour.